Oh my gosh. Okay, we're going to do calculating principal with simple interest. This time, let's say that you have, actually, no, let's say, since we're calculating the principal, we want to have $1,000, okay? We want $1,000, and we want to have it by 5 years from now. So 5 years from now, because we want to maybe buy a car or whatever the heck it is we want to do. And the bank is going to give us an interest rate. Let's say bank will give us interest rate of 2%. Okay. Our question is, what is the principal? How much money do I got to put in now to get $1,000 in 5 years if the bank will give me 2% interest? So, let's take a look at our formula again. A equals P plus PRT. So, we have to isolate P. The problem is, well, what we've learned in this far in mathematics is to isolate we need one variable. Right now, P is occurring twice. So we have to change it so it's only showing up once in this equation. So, do you remember common factoring? Mm-hmm. Because there's a P in both of these, we can common factor out the P. So another version of this formula is written like this. A is equal to, we divide by P. So P comes outside the brackets. Okay. P divided by P would be 1. Okay. Plus, you can write 1 here, but it doesn't make a difference. So 1 plus RT. This is another form of, is yellow a good color for this? It's not the greatest. That's another form of the formula, okay? I did not like that. That did not come out nice. There we go. That's a good version of it. So remember how we showed you, or right above it, I've written P plus PRT. You can also write P times 1 plus RT. This one helps us isolate variables really well, okay? It doesn't matter. You can always start from the same one, but this is a great version of it. So what do we have? Well, we have the amount. How much did we want 5 years from now, did we say? 1,000. Great. Oh, there you can change the colors. So our A, which is our future amount, is going to be equal to $1,000, okay? The P, the original put in, do we know what it's going to be? No, that's unknown to us. What about R?
2%.
2%, which is what as a
decimal.
Great. So we turned into a decimal. And times, how much time? 5 years. We'll say T is in blue here. And we're going to say that was 10%, 2% per year. I didn't specify that. That's really, really important, okay? Okay, so now that we've done that, we need to isolate for a variable. I'll highlight it in green here. We need to isolate for our P. Okay? So let's calculate this over here. We still have 1,000 is equal to P. This 1 plus 0.2 times 5, I think, is actually going to be 0.1. We should double check that after. Which means 1,000 is equal to P 1.1. We're going to have to bring it over to the other side. So divide both sides by 1.1. Oops, that's a very terrible one. And P will be equal to, give me a calculator there. So like 900-ish. $909.09. Amazing. $909.09. So according to this, we needed an original principal of 909.09 in order to get $1,000 in the future. We can technically prove this. We'll test it. Okay, let's test this hypothesis. Well, let's say we don't know the amount in the future, but we know the principal is going to be 909.09. I'm going to use the second formula we used, okay? Times 1 plus 0.02 times 5. So I'm using the second version of the formula. If we run these numbers, it should end up with A at 1,000, okay? So let's do a quick run of this. This is still going to be 1.1, so it's going to be 909 times 1.1. What does that give us? $999.99. Most likely the bank, well, in Canada we round up now, so this is for sure going to be $1,000. Okay, so it works out great. Okay, does that make sense how to isolate principal?